Today we're going to look at checking solutions to functions. That's on page 66 in our interactive notebook. Okay, so title page on the left and then your other page on the right. Okay, so today we're basically looking to see if we kind of go in reverse order. What if all that work is already done for us? How can we tell if it's right or wrong? Okay, so if we've plugged in the input, we've got its corresponding output, how do we tell if it's correct? Okay, so if we want to determine if an ordered pair is a solution, we're going to have to plug in the x value, which is our domain, and see if it then matches our output of the range. Okay, if it does match, it is a solution. If it doesn't match, then it's not a solution. Okay, so for example, if we look at this and we want to decide if 8, 7 is a solution to y equals 6x minus 41. Right? We know this is an ordered pair x, y. So we are going to take this x value of 8 and plug it in for 8. Okay, so instead of saying 6 times x minus 41, I'm going to say 6 times 8 minus 41. Well, 6 times 8 is 48. And 48 minus 41 is 7. We then want to check and see if that corresponds to the output value that it said we should get. We got 7 as an output value. It says we should have 7 as an output value. Those are both the same thing. That's true. So this is a solution. Now, this can then be presented to us in different formats. So what if it's presented to us in function notation? Well, still the same idea. We want to take our x value and plug it in for x. So we're going to take 1/5 times 15 plus 8. Now if you're like, oh, I'm bad at math or whatever, use your calculator. All right, so 3 plus 8 then gives us 11. So now we're going to check. Is 11 the output value it told us we should get? We got 11 as an output, but the output it told us we should get is 14. Those numbers are not the same, so this is not a solution. Okay, table format, same thing. We would still look at this and treat this like this is an ordered pair, -5, 30. So we're still taking that x value and plugging it in for x. We're just gonna have to do it multiple times, so we're just checking the work. So if we say -3 times -5 plus 16. Well, 3 times 5 is 15. 15 plus 16 is 31. This says that we would get out 30, so no, this is not a solution. -3 times -2 plus 16. Well, -3 times -2 is +6. 6 plus 16 is 22. That is what it says we should get out, so this would be a solution. Plug in 7. -3 times 7 is a -21. -21 plus 16, let's see, is a -5. Yep, we agree, so that's a yes. -3 times 9 is -27. -27 plus 16 would be -11. So this does not match. So that's a no. -3 times 15 would be a -45. Oh, let's see, -45 plus 16 would give us a -29. And so those do match, and this would be a yes. Oh, not 2 S's, just 1. Now, it's nice and simple when it's already solved for y for us. The catch is that if it's not solved for y, right, it's given in a different form. So maybe like in the form ax plus by equals c, which we've been solving for y, we'll just have to either A, solve it for y, and do exactly what we were doing. Or B, substitute in both the x and y value at the same time and simplify it down. Okay, so if the simplified work is a true statement, then we would say yes, it is a solution. If the simplified work is a false statement, then we would say no, it's not a solution. So I'm going to do both of these with one of these options. I'm going to be honest, if you're efficient at solving for y, especially if there's more than one to check is what I should say, I guess. If you're good at solving for y and there's more than one to check, like maybe it's in table format, I would definitely go the route of solving for y. If there aren't multiple to check or you struggle solving for y, then not solving it and plugging them both in would be your option. Okay, so for this first one, I'm going to go the option of solving it for y. Okay, so if we solve this for y, we want to move this x over. We've done several times of solving for y now, so hopefully we're feeling a little bit more confident in it. And then we'll divide by that -2. Two negatives make a positive. Okay, and then we'll divide that 32. Two negatives here also make a positive, but we'll get positive 16. And then we'll just go the approach that we have been doing. So we'll take this x value, which is -5, and we'll plug it in for x. So 2 times -5 plus 16, so -10 plus 16. That gives us 6. 6 is what we did have up here, so yes, this is a solution. If we don't want to go the route of solving for y, then we are going to have to substitute both of the values. Okay, so we are going to have to know that this is an ordered pair of x comma y. So when it says 14 times x, we'll say 14 times 3. 7 times y, so now instead of putting y, I'm also plugging in that y value of -5. And I'm going to check and see if all of this is now equal to 98. This starts to be bigger numbers, so I'm going to use a calculator. So 14 times 3 gives me a 42. You could plug it all in your calculator in one big old long thing, plus a -35. Well, I can already tell, right? That's going to be something smaller. So this gives me 7. Does 7 equal 98? No, right? This is a false statement, so we would say that this is not a solution.